we are starting a chapter solid state. Now we all know that we have three states of matter, that is a solid, liquid and gases. Under a given condition, depending upon the intermolecular forces, the intermolecular space and other factors, we decide whether the given substance is in a solid state or liquid state or in a gaseous state. About the liquid state and the gaseous state, we had already learned in the chapter, that is the states of matter or the gaseous state chapter. Here we are going to learn only about the solid state. So let's first start with the characteristic of a solid. What are the different characteristics of a solid? A characteristic the solid is having. So characteristics of a solid. So first characteristic, the solid have a definite shape, definite mass and the definite volume. So it have the definite shape, mass and volume. The second characteristic about the intermolecular force of attraction. Intermolecular forces. In case of solid, the solid particles, the intermolecular force of attraction between the two particles is a very strong. So they have a strong intermolecular force of attraction, and due to that strong intermolecular force only I can say that they have a definite shape and a definite volume. Then since the intermolecular force of attraction is a very strong, so when the molecules are arranged or the particles are arranged, the gap left between them is a very small, which is called as an intermolecular space, or we have one more name that is called as a void. So here I can see the intermolecular space or the voids are smaller in size. So voids are comparatively smaller in size compared to the liquid state and the gaseous state. Since the particles are since the intermolecular force of attraction is a very strong and the voids are very small, that's why they are rigid in nature and they have a very compact structure. And since they have a compact structure, therefore the density of the solid is much higher than the density of the liquid and the density of the gaseous state. So they have a very high density. The solid have high density. Since the intermolecular force of attraction is very strong, so molecules are tightly packed with each other. That means I can say that there is no space, like already the molecules are very close to each other. So by applying a pressure, bringing those molecules even closer is not possible. That means the solids are almost incompressible. So they are incompressible. The next characteristics. Since the intermolecular force of attraction between the solid particles are very strong, and intermolecular force of attraction is very strong, that means there is a no motion or the very less motion between the solid particle. And since their motion is a very less, the solid particles are not free to move here and there. So because of a very strong intermolecular force of attraction, the molecule just keeps on oscillating on their position, just they vibrate, they do not move here and there, and that's why their kinetic energy, the molecule's kinetic energy is very low. So the solid molecule, the molecules having a very low kinetic energy. Then when a solid is heated, when a heat energy or the thermal energy is applied to the solid, after heating, the intermolecular force of attraction gets weaker, and since as the intermolecular forces are getting weaker, then I can say that the solids slowly start converting into the liquid state. So on heating, the solid get converted into liquid state, and that process is called as melting. So it undergoes melting process. After that, the solid, in case of solid, the rate of diffusion is very low, because the solid, in case of solid, the intermolecular forces are very strong and the voids are very small in size. So they do not diffuse easily. Diffusion, that is a mixing. So they do not diffuse easily. That solid to conversion of a solid into liquid is also known as a fusion, that is the melting, or I can say it's a fusion. So if I'm saying that the solid undergoing a fusion process, it means we are melting a solid from solid state to liquid state. Now here let's talk about the types of a solid. we have two main types of the solid, that is called as a crystalline solid and amorphous solid. So here we have two types of a solid. Crystalline solid, and the second one is amorphous solid. Now let's see what are the differences between the crystalline solid and the amorphous solid. So the difference between the crystalline solid and the amorphous solid. Now in case of crystalline solid, this is for the crystalline solid. Here I can say that in crystalline solid, whatever the particles we have, once I use the word particle, it means it may be atom, or it may be molecule, or it may be ions, depending on which type of solid is taken. So here in case of this, whatever the particles we are having, these are nothing but the particles which are represented by this dot. So you can see that here all the particles are arranged in a definite order. There is a fixed arrangement of a particle. While in the case of amorphous solid, this diagram represents the amorphous solid. Here we can see that there is no fixed arrangement of a particles. The arrangement is not regular. That arrangement keeps on changing in this case. So in case of crystalline solid, I can say that there is a regular arrangement of a particle. So here we have regular arrangement of particle, while in this case the particles are arranged in irregular manner. No fixed arrangement. In the case of crystalline solid, at least I can explain the arrangement of a particle, how the particles are arranged. Like in this case, I can say the particles are arranged in a cubic manner. All the particles are arranged in the same manner. While in the case of amorphous solid, such same type of arrangement is not observed. Somewhere it is a cubic, somewhere it is a pentagonal, then triangular. So that arrangement is not fixed. Since all the particles are arranged in a definite manner or the definite order, that's why they have a definite shape. While in case of amorphous solid, since the arrangement is not proper, therefore they do not have definite shape. Here the next property I can say that they have sharp melting point, that is a crystalline solid. We say that crystalline solid have a sharp melting point. Sharp melting point because here the arrangement of the particle is a fixed, so the particles, since the arrangement is a fixed, so intermolecular forces are also same. So whenever we heat them, they melt at a particular temperature. For example, suppose if I am saying this is crystalline solid is having a melting point 70 degrees Celsius. So when it is heated exactly at a 70 degrees Celsius, it is going to be a melt. That means have a sharp melting point. But in case of amorphous solid, they do not have a sharp melting point. Instead, they melt over a range of temperature. For example, suppose if this amorphous solid, if someone is asking that what is the melting point of this amorphous solid, then instead of telling him that is a fixed melting point, we just gave a range that somewhere it will melt between 70 to 75 degrees Celsius. Because their melting point is not fixed. So they have sharp melting point, while this do not have sharp melting point. In case of this third property, the next difference, since they have a sharp melting point, so I can say that they have sharp enthalpy of fusion also. So they have sharp enthalpy of fusion, while this do not have sharp enthalpy of fusion. Do not have the sharp. What is enthalpy of fusion first? Enthalpy means the amount of heat absorbed or evolved. Fusion means, as I said, it is a process in which the solid is converted into a liquid. That process is called as a fusion, and that process requires certain amount of heat. So whatever the amount of heat is absorbed or it is required to convert a 1 mole of a solid into a liquid state, 1 mole of a solid into liquid state is called as enthalpy of fusion. So if you want to convert or if you want to melt it, then for melting a fixed amount of energy is needed. For example, here I can say like 80 kilojoule energy is required. So 80 kilojoule, once I said, that means exact 80 kilojoule is required to fuse that particular crystalline solid. But in the case of amorphous solid, they do not have fixed enthalpy of fusion. Again, here instead of having an exact enthalpy of fusion, here again we have a range of energy. That means I will say somewhere it will melt between 80 to 80. It will require 80 to 83 kilojoules of energy for the fusion process. That is for melting. Here I can say that melting point and the enthalpy of fusion both talks about the same process, that is a conversion of a solid into liquid state. Only the difference is that when I'm saying melting point, we measure temperature in this case. But when I'm using a word enthalpy of fusion, that means here we are measuring the amount of energy, and the temperature and energy dependent on each other. If the energy required is a fixed, then temperature is also going to be fixed. The same thing here I can say, since the energy is not fixed, we are not having since they do not have the fixed amount of energy, that's why the temperature, that is a melting point value, is also not definite. The next I can say about the cleavage property. Cleavage property, that is a cutting property. Now, when we cut a crystalline solid, on cutting a crystalline solid, we get a smooth surface. While in case of amorphous solid, when they are cutted, instead of getting a smooth surface, we get a rough surface. For example, I can say that suppose if I am cutting an iron block, a block of iron, when iron block is cutted, the new surface which we are getting is a smooth surface, because the iron is a metal and the metal is a type of a crystalline solid. But at the same time, when the glass is cutted, take a block of glass, and when it is cutted, the block of glass, the new surface which we get is do not have a smooth surface. Instead, it have rough surface. Because the glass is considered as an amorphous solid, that's why it produces rough surface. So cleavage property, this produces smooth surface on cutting, while this produces rough surface when it is cutted. The next, the crystalline solid is having a long range order. While in case of amorphous, we say that they have short range order. Now, what is the meaning of this long range order and short range order? Now, in the case of crystalline solid, as I said, that particles are arranged in a definite manner, and the same arrangement keeps on repeating throughout. And if the same arrangement repeating throughout, then we say that it is that's why it is said that they have a long range order. That means to a long range, their arrangement is same. While in the case of amorphous solid, it has been observed that in certain amorphous solid, the arrangement of a particle repeated, but that repetition is only through some angstrom, beyond which again the repetition get disturbed. That means we get an irregular arrangement of the particle. So in case of amorphous solid, if there is arrangement is observed, the same repetition of the arrangement of particle is observed, then it is only to a certain length. After that, again we get the same disturbed arrangement of a particle, and that's what is known as short range order. Crystalline solid, they are anisotropy or isotropy, while this amorphous solids are also always known as isotropy. Now, what is this anisotropy and isotropy? Let's see the difference between the term anisotropy and isotropy. Suppose I have a crystalline solid like NaCl. Let these are Na plus ions. and these are Cl minus ions. That is NaCl, which is made up of a cation and anions, and there is a ionic bond present between them. Now in the case of NaCl, when certain physical properties are measured, then it has been observed that the property keeps on changing. Now certain physical property, for example, suppose I wanted to measure the electrical conductivity or the thermal conductivity or refractive index. So suppose here I measure the electrical conductivity in a different direction. First I measure the electrical conductivity in this direction. In this direction. Then I measure the electrical conductivity from here. Then I'm measuring the electrical conductivity in this direction, and then the electrical conductivity is measured in this direction. When I measure the conductivity in this direction, I got a value for the electrical conductivity as a 0.45. In this direction, when I measured here, suppose I got a value 0.46. Here I am getting a value 0.48, and in this case I am getting a value 0.41. So I can say that in the case of NaCl, when the same property is measured in a different direction, we are getting a different value. Then a solid having a such type of a solid which gives the different values in a different direction is called as anisotropy. For example, suppose I am having this particular solid. Now in this particular solid I am measuring the electrical conductivity. First I measure the electrical conductivity in this direction, then I am measuring the electrical conductivity from this direction, and then I am measuring here. So, and then diagonally. So when we measure the electrical conductivity or any physical property, and if it gives a different value, then we say that it is anisotropy. But at the same time, if the property measured in the same all the direction gives the same value, then such solids are called as having a isotropic property. So if the values are different, anisotropy, but suppose if the values obtained in all the cases will be same, then it will be called as isotropy. Now in the case of crystalline solid, the crystalline solids are anisotropy or it may be isotropy, but amorphous solid, whenever the properties are measured in a different direction, always gives the same value, and that's why the amorphous solids are considered as isotropy. Now in case of crystalline solid also, it's not like all the crystalline solid shows the anisotropic property. There is only one specific type of crystalline solid is known as ionic solid. Only the ionic solid which are made up of the two different types of a particle, that is called as a cation and anions. And since it is made up of two different types of particle, that's why it shows an anisotropic nature. Now why we are getting a different value in the case of this NaCl? Then the reason is that when you measure in this direction or in this direction, then it may be possible that here the particles are different. For example, in this direction only Na plus, from here only Cl minus, and the conductivity of Na plus and Cl minus may be different. And since the conductivity will be different, so depending on which ion is present in a more, like in the path which ion comes more, depending on that the value keeps on changing. And this happens only in the one type of crystalline solid, that is ionic solid. And while the other type of crystalline solid possess isotropic property, but in case of amorphous solid, since there is a no definite arrangement of particles, so it always shows isotropic property. Then crystalline solids are also known as crystalline solids are also known as homogeneous solid, or true solid, while amorphous solids are known as heterogeneous solid or pseudo solid. Now this is known as homogeneous solid. Homogeneous solid, the simple reason I can say, since they have the same arrangement of particle, that's why they are called as homogeneous solid. But in the case of this or true solid, why we use the word true solid? The reason behind it is that whatever the things or whatever the characteristic or the properties are expected in a solid, all those properties are observed in a case of crystalline solid, and that's why the crystalline solids are called as true solid. While the amorphous solids are known as a pseudo solid or heterogeneous solid, or it is also known as supercooled liquid. Pseudo solid, it is called pseudo solid, the reason because whatever the things are expected, what all the properties which are expected in a solid is not shown by this amorphous solid. For example, we say that in solid they have a definite shape and the definite volume, but in the case of this I said that they do not have a definite shape. There is a no proper arrangement of a particle. So all the properties of a solid is not possessed by this amorphous solid. That's why they are called as pseudo solid. They are also known as supercooled liquid because somewhere they have some property common like a liquid, and that's why they are called supercooled liquid. The property, which property of a liquid? Then I can say fluidity property. So amorphous solid, somewhere I can say it is an intermediate between the solid state and the liquid state, which possesses the properties of both, means it's a purely not a solid and not liquid. So this is the difference between, these are the difference between the crystalline solid and the amorphous solid. Now let's see the certain terms which are used in the chapter that is a solid state. The one is called as isomorphous and polymorphous substances. So what is isomorphous and polymorphous? Isomorphous substances. Iso means same. Morphous means structure or form, I can say, or same structure or the same arrangement of the particles. So isomorphous substances, if two or more different substances are having a same arrangement of particle, then they are called as isomorphous. Two or more different substances having same arrangement of particle or same shape of particle, then they are called as isomorphous substances. Example, I can say here the sodium fluoride and magnesium oxide. Both are the different substances, but they exist with the same crystalline structure, the same form, the same arrangement of particle is observed in the case of both. The second one, K2SO4, that is a potassium sulfate, and K2SeO4, that is potassium selenate. Again, the substances are different, but their structures or the crystalline form is the same. The arrangement of a substance is the same. Third, sodium nitrate and calcium carbonate. So these are the examples of the certain isomorphous substances. Now it has been observed that in case of the isomorphous substances, two or more substances which are considered as a isomorphous, they have approximately same arrangement, their atomic ratio is same. Means if the two substances are isomorphous, then their atomic ratio is same. Let's see the same thing. Here in case of sodium fluoride, I can say there are the two atoms, that is the sodium and fluorine, and the ratio of sodium and fluorine is here the 1:1, and the same ratio I can observe, we can see in case of magnesium oxide also. In case of magnesium oxide also, the ratio of magnesium and oxygen is 1:1. Here we have the two substances, that is a potassium sulfate and potassium selenate. Here we have total 3 atoms and the ratio is the 2 potassium, 1 sulfur and 4 oxygen. That is the ratio of the atom in this compound is 2:1:4. And you can see that the same ratio is present in the case of this potassium selenate also, that is K2SeO4. In case of sodium nitrate and calcium carbonate, the ratio of the atoms are again same, that is 1:1:3. So here I can say that it has been observed that if two or more substances are isomorphous, then the ratio of the atoms in those compounds are also same. But it doesn't mean like if two substances are having a same atomic ratio, then they are going to be isomorphous. Isomorphous substances have a same atomic ratio, but atomic ratio, if atomic ratio is same, that means the substance will be isomorphous is not correct. Because we are having a certain example where I can say the substances are having a same atomic ratio, but they are not isomorphous. The example I can say sodium chloride and cesium chloride. The atomic ratio of sodium chloride, in case of sodium chloride, the atomic ratio is 1:1, while in case of cesium chloride also the ratio is 1:1. So they have same atomic ratio, but they are not isomorphous. The next is of isomorphous. The opposite of isomorphous is polymorphous substances. Now what is polymorphous? Poly means many. Morphous means again form or structure, I can say. So polymorphous. If the same substance exists in nature with a different crystalline structure, then they are called as polymorphous. The same substance with a different structure. The example we had heard about the carbon. The carbon exists in nature in the three different forms. That is a graphite, diamond, and fullerene. So carbon is called as a polymorphous substance because it is existing in nature with the three different forms. Then here I can say after carbon, the next is phosphorus. We have the phosphorus also exists in a three different polymorphic form. That is, we can say that for the phosphorus, we have red phosphorus, black phosphorus, and white phosphorus. Similarly, we have sulfur. The sulfur we have rhombic sulfur, monoclinic sulfur. So there are the various substances which are existing in a nature with a different crystalline structure, the different arrangement of the particle, and such substances are called as polymorphous substances. The polymorphous substances and allotropic substances are somewhere looks like or appear same, but there is a small difference between the term allotropes or allotropy and the polymorphous. When we say the allotropic form of the carbon, then again we say that having a substantially different structure. But allotropes, in case of allotropes, we consider amorphous form also, amorphous as well as crystalline form. But when we use the term polymorphous, we only consider its crystalline form. We never consider amorphous form. Now in case of carbon, if the question is what are the allotropes of carbon, then I will say the carbon allotropes are graphite, diamond, fullerene, charcoal, coke, lamp-black, etc. Where the charcoal, coal, lamp-black, they all are crystalline form. But when the question is that what are the polymorphous form, what are the polymorphic form of the carbon, then the carbon polymorphic form is only three. That is diamond, graphite, and fullerene. So polymorphous, it is applicable only for crystalline solid. That means it only consider crystalline form, not amorphous form. Then for the amorphous substances, we use a term that is called as pseudo-solid or supercool liquid. So amorphous solid or supercool liquid. Now why we use such type of word for the amorphous solid? Pseudo solid, because as I said, pseudo means it is a false. That means pseudo solid means the amorphous solids are considered as a false solid. The reason I said because they do not shows all the properties of the solid. All the properties of a solid is not present in the case of amorphous solid. That's why we call it as a pseudo solid. And also known as supercool liquid. The reason for calling it as a supercool liquid, I said that they shows us some properties of a liquid also. Which property of a liquid? Then I said it's a fluidity property. Amorphous solids are those solids which flow. Every solid flow, but every solids flow when it get converted into a liquid state. That is after its melting point, above its melting temperature. But the amorphous solid are those solids which start flowing even in a solid state. Means they flows in a solid state. Let's see the example for the amorphous solid or the supercool liquid. The example is a glass. Glass is an example of a supercool liquid which shows the fluidity property. Suppose I have a window pane. This window pane is fitted with a glass. This is the glass with which it is fitted. Now in the beginning, when the glass was fitted in a pan, the thickness of the glass was same throughout. That means the thickness of a glass was uniform. The thickness at the top or at the bottom or at the middle part, it was same. That is when the glass was fitted in this. But after 15 years, suppose I am measuring again the thickness after 15 to 20 years. Now what I observe after 15 to 20 years, I come to know that the thickness of a glass on the upper part of a pan has been reduced, while on the lower part of the pan has been increased. Means here the thickness has reduced and here the thickness has increased. The question arises that how the thickness changes, because when the glass was fitted, that time uniform thickness glass was used. That means the thickness was same. So why the glass thickness has been reduced here and it has been increased? The reason is that glass is a super cool liquid. It shows a fluidity property. Continuously up to 15-20 years it gets heated from the sunlight, and due to that heating, what happens? The glass start flowing. But the rate of flow of glass is very slow. But still the glass is flowing, and due to the gravity the glass start flowing in a low downward direction. And when the glass flows in a downward direction, ultimately on the upper part the thickness of a glass decreases because the amount of a glass reduced, while on the lower part all the glass after flow it get accumulated on the lower part, that is the thickness on the lower area is increased. So this proves that the glass flows. That's a different thing, that the flow of a glass is very less. Another example, I can say the tar which we use for making a road, that is a pitch. The tar is also considered as an amorphous solid. The simply I can say, suppose I took a spherical shape of a tar. I took it as a spherical shape, and you suspend it with the help of some wire. Suspend it with the help of some wire and keep it in a sunlight, or for 1, 2, 3, 4 months, or for 1 year. When after 1 year or after certain time, you will observe that the shape of the star has been from spherical shape, it has been slowly getting converted into the elliptical form, or slowly it is getting in elliptical form. It's converting into the elliptical form, like the shape is getting something like this. Now this thing is happening, from this the shape has been converted to this one, and this is happening because due to the sunlight hitting, again tar shows being a super cool liquid, the tar also start flowing, and due to that flow and due to that gravity the tar is moving on the downward side, and that's why the shape is getting converted into this form. So the tar, glass, rubber, plastic, these all are considered as a amorphous solid, as well as they are super cool liquid. They are called super cool liquid because under a small hitting, when they are in a solid state, they start flowing. That's a different thing, that the rate of flow is very slow. Now here we have a structure of, this is a quartz. This is the structure of a quartz, that is silica, or it is a sand. The quartz, from the structure I can say that this is in a crystalline form. This continuously increases, the size goes on increasing. But here I can say that in case of quartz, they have the definite shape or the definite arrangement of the particle. In case of quartz, it is formed by the tetrahedral unit of the SiO4, where each silicon atom is tetrahedrally bonded with the 4 oxygen atom. And as I said, the arrangement appears crystalline due to the regular arrangement. Now, when this quartz is heated at a high temperature, when the heating is done, it melt out, and after melting, again when the cooling is done, then after cooling it produces such type of structure. Means when the cooling is done, the question, after cooling, first it was a solid, then melted into the liquid state, and after cooling it was expected that again the solid will get converted into the same format. But surprisingly, the solid, instead of attaining during the cooling attaining the same structure, it get converted into this form. And this arrangement here, the arrangement of particle, on the basis of the arrangement of particle, I can say that this is an amorphous solid, because here the arrangement is not fixed. Means a crystalline solid, after a heating, when it get converted into liquid state, and when it is cooled, again it get converted into amorphous form. And this amorphous form of the quartz is known as a glass. That is called as a quartz glass. And we all know that the glass is an amorphous solid. The question arises that why again the solid fail to attain the same crystalline structure. It doesn't happen in the case of all the crystalline solid. For example, suppose if I'm taking ice itself. Ice, it is a crystalline solid. When it is melt, it get converted into water. Water will have no arrangement because it is not a solid, it is a liquid. But when the water is again freezed, on freezing, the water again produces the same ice with the same crystalline structure. But this doesn't happen in case of quartz. When it is cooled, after cooling, instead of attaining the same structure, it attains this structure. And the reason behind it is that it get this structure because here the rate of crystallization is very fast. Rate of crystallization is very fast means the conversion of a liquid into the solid, the process is a very fast, and due to that very fast process, the solid particles didn't get the proper or the enough time to arrange them into the crystalline, that is into the regular form, and that's why due to the lack of time its arrangement get disturbed and we get an amorphous form. So if the glass has to be prepared, if I wanted to prepare a glass, then quartz is heated at a high temperature and then it is cooled so that we get a amorphous substance, and that amorphous substance is called as a quartz glass. So this is about the isomorphous substance, polymorphous, and about the pseudo solid or supercooled liquid. So supercooled liquid, keep in mind that amorphous solid is an intermediate between the solid state and the liquid state, which possesses the property, the main property of the solid, but in addition to that it have the some properties of a liquid also.